the multiple base exponent properties, we're going to let x, y, m, and n be real numbers with x and y different from 0. Property 5 is the product rule, so when you multiply the same base, you can add the exponents. So x to the m times x to the n is x to the m plus n. So x times x to the third is really x to the 1 times x to the third. So we can add the exponents 1 plus 3 to get x to the fourth. A to the third times a to the negative second times a to the 10. We can add the exponents 3 plus negative 2 plus 10 to get a to the 11th. Property 6 is the quotient rule. So when dividing by the same base, you subtract the exponents. So x to the m over x to the n is x to the m minus n. So x to the 5th over x to the 3, we'd do x to the 5 minus 3, which is x to the 2nd. Or a to the 1, a over a to the 10 is a to the 1 over a to the 10. So we'd subtract a to the 1 minus 10, which is a to the negative 9. That's written as a negative exponent, so we would flip it on a fraction, 1 over a to the positive 9. Alternately, if you see that you have a higher exponent on the bottom of a fraction, you can subtract from the bottom. So for this problem, that would look like 1 over a to the 10 minus 1, subtracting the a to the 1 from the a to the 10 on the bottom to get 1 over a to the 9. So either of those methods is okay. Property 7 is the power of a product or quotient. When you have that situation of a product with a power on the outside, you distribute the power to both things or all things on the inside to get x to the m, y to the m. Same thing with a quotient. If you have x over y to the m, we would distribute the m power to both the top and the bottom. This should be y to the m on the bottom. So for example, 2x to the third, we distribute the 2 into both of these terms, or both of these pieces. So 2 to the third, x to the third. And then 2 to the third we can evaluate to 8, so 8x to the third. Okay. With the second one, 5xy squared, then xy to the fourth, we distribute the 2 in to get 5 squared, x squared, y squared, and x to the fourth, y to the fourth, when we distribute the 4 into the second parentheses. Okay, then simplifying this, we would have 5 squared is 25, and then we would add the powers of the x's, so x to the 2 plus 4 is x to the 6, and then y to the 2 and y to the 4, so y to the 2 plus 4 is y to the 6. Okay. And last example, x over 3y to the second, that's a power of a quotient, so we're going to distribute this squared power into this quotient to each term. So that would be x squared over 3 squared y squared. And we can evaluate the 3 squared, which is 9, so x squared over 9y squared. Okay. Using those properties and the ones from the previous section, complete problems 7, 8, and 9.